First hour, Algebra 1. We're going to start this week off with something new. Last week was all review. We're going to learn something new today, and that is how to solve equations with logs in them. Okay, these equations can fall into two categories. Either they have logs everywhere, meaning everything you see all the way across your problem has a log in front of it, or they could be missing a log somewhere. You see here on this x does not have a log in front of it. Okay. So that's the two categories. That's kind of how you'll recognize and identify your equations. Do they have logs everywhere, or are they missing a log? Now, if they have logs everywhere, we kind of had a problem similar to this already. Remember when we have something like 2x equals 2 to the 7th. If these bases are the same, then the exponents don't have a choice but to be the same. Same kind of thinking works here. If these two logarithms are the same, then these two places right here don't have an option but to be equal. Now that x and that y, those are called, the actual name of that location in a logarithm is called the argument. So the arguments are equal. Okay, so if the logs are the same, arguments are the same. Just like exponentials are the same, or the bases are the same, the exponents are the same. Now if we're missing a log somewhere, this is simply set up for us to do the hook. Remember doing the hook? What would the hook tell me here? It would tell me a to the power of x equals b. Remember, base and base are the same. The answer to a logarithm comes from an exponent, all that good stuff. Remember how to do the hook. And this is how we'll solve these two types of equations. Okay, on to our first two examples. So here we have one of each type. So I notice in my first equation, it is a log equals a log. So that simply means since these are both log-based 7s, all I have to do is drop my arguments down, 4x minus 5, and set it equal to the other argument, 2x minus 1, and now we have an old type equation. We would subtract 2x, get a 2x, add 5, and get 2x equals 4, so x is equal to 2. In our second example, we're missing a log on the right-hand side. What's that tell us? Do the hook. Okay, what would the hook tell me here? 5 to the second power equals x plus 5. So 25 equals x plus 5. Subtract our 5, we get an answer of x equals 20. Okay, that's all there is to our two types of equations today. So on these next two examples, why don't you press pause, work the problem, and then come back and press play and see if you got them right. Okay, in problem number 3, they both are log base 3s. So, and we have logs on both sides. So all we need to do is 5x plus 1 equals 3x plus 9. So we get 2x equals 8, x equals 4. Okay, we're missing a log on number 4. That just simply means to do the hook. We need to recognize that. And the hook tells us 2 to the 4th power equals 3x plus 5. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. Subtract our 5, we'll get 11. Divide by 3, we get an answer of 11 thirds. Okay, x equals 4 on number 3, x equals 11 thirds on number 4. And that's all there is to it, guys, with these two types of equations. Tomorrow we'll expand on this a little bit. There'll be a little bit more to them tomorrow. But for today, this is it. Okay, so I have attached a homework worksheet. You can do that, and we'll check those answers tomorrow. Goodbye.